Hello all. The third module of mechatronics deals with the micro electromechanical systems, which is commonly known by its short form MEMS. This module covers the introduction to these MEMS as well as the various fabrication methods used to develop these micro electromechanical systems. Finally, a few examples for the practical applications of these MEMS are also discussed in this module. So the introduction to MEMS. Now, the second half of the 20th century witnessed a rapid improvements in the semiconductor as well as the integrated circuit technology. Now, this led to the development of MEMS. So, these are basically the interdisciplinary process technology that are used to create tiny devices that combines both the mechanical and electrical components. Now, previously, most of the systems or machines were almost purely mechanical and the electrical components were very few. However, with the development of these semiconductors as well as circuit technology, most of the mechanical parts or the mechanical components were replaced with electrical components. This led to the rise of actuators and sensors which were electrical or electronic in nature. Thus, the systems or machines were interdisciplinary in nature, which means that it consists of mechanical and electrical components to do the intended work. The development of micro electromechanical systems or the MEMS also led to the replacement of bulky mechanical components using tiny electrical components. Thus, the size of the MEMS range from certain micrometers to a few millimeters, which was the major advantage over the mechanical components. Now these MEMS, they can sense, control and actuate on the micro scale, and they can generate the effects on the macro scale as the mechanical systems. They consist of mechanical microstructures, microsensors and microactuators and the microelectronics, which were all integrated onto the same silicon chip or the integrated circuit. Since the size of these sensors and actuators were micron levels, the size of the chip was also so small than compared to the bulky mechanical parts. The microsensors can detect change in the system's environment by measuring the certain physical parameters. The microelectronics or the microcontrollers this process this information and signal the microactuators to react and create the intended changes to the environment or the mechanical systems. The figure shows the various components of the MEMS, which are microsensors, microactuators, microelectronics, and the microstructures, which are the mechanical parts. Now the classification of MEMS. Now this MEMS is a combination of ultra precision microengineering and IC technology or the integrated circuit technology. The manufacturing of micro electromechanical components or the systems are based on micro machining and various other fabrication techniques which we will learn later. And the IC technology or the chip technology is used to form the system or form the connections between the sensors, actuators and the processors. So the density or the scale of integration, which is the number of components on the chip or the circuit to make the system work or the device work. So based on this density or the scale of integration, the MEMS are classified as small scale integration, medium scale integration, large scale, very large scale and very large scale. The very large scale integration or the VLSI is very popular term and is a separate branch of the electronics. The applications of micro electromechanical systems. Since the MEMS are very small in size in the micron range, they can easily replace the mechanical components of the systems. As a result, they are found in a variety of fields in our day-to-day life. Now the table shows some of the applications of the MEMS in different fields. The airbag sensors of the automotive cars and trucks is one of the famous applications. The inkjet printer heads and the projection screen televisions utilizes the MEMS for their application in electronics industry. The pacemakers for the human hearts to prevent the heart attacks is one of the application of MEMS in the medical field. Similarly, the beam splitters and the couplers as well as the fiber optic network cables for the communication industry. The defense industry uses the for MEMS for surveillance as well as data storage as the important applications. There are a lot more applications for MEMS across the various fields.